Over a century, AGC has been an innovator in various industries. We've brought comfort to people's homes, entertainment into their lives, and we've been helping people to get from place to place faster and safer. We have brought communities together with our products. We offer a wide range of materials such as glass, electronics, chemicals, and ceramics. And operate in over 30 countries and regions with over 50,000 employees, working to provide essential products for day-to-day life. Our research and development team thrives to achieve a better society and standard of living. At any point in time, AGC has played a part in supporting society, providing unique materials and solutions. Our glass is used in buildings and vehicles around the world. Our chemicals business offers a wide range from daily products such as baking soda to materials used for iconic buildings around the globe. Furthermore, providing solutions to advanced medical care and expected food shortage issues. Our display glass enables clearer images. By utilizing a wide range of technology, AGC contributes to the development of the electronics industry. By providing unique materials and solutions, AGC is always around you, supporting people's lives anywhere in the world. AGC, an everyday essential part of our world.
For over 20 years, Glasstech Asia has served the ASEAN glass industry as the main meeting point in the region. Together with Fenestration Asia, Glasstech Asia moves around Southeast Asia and regularly attracts over 200 suppliers showcasing leading technologies together with more than 3,500 buyers from the region.
Over a century, AGC has been an innovator in various industries. We've brought comfort to people's homes, entertainment into their lives, and we've been helping people to get from place to place faster and safer. We have brought communities together with our products. We offer a wide range of materials such as glass, electronics, chemicals, and ceramics. And operate in over 30 countries and regions with over 50,000 employees, working to provide essential products for day-to-day life. Our research and development team thrives to achieve a better society and standard of living. At any point in time, AGC has played a part in supporting society, providing unique materials and solutions. Our glass is used in buildings and vehicles around the world. Our chemicals business offers a wide range from daily products such as baking soda to materials used for iconic buildings around the globe. Furthermore, providing solutions to advanced medical care and expected food shortage issues. Our display glass enables clearer images. By utilizing a wide range of technology, AGC contributes to the development of the electronics industry. By providing unique materials and solutions, AGC is always around you, supporting people's lives anywhere in the world. AGC, an everyday essential part of our world.
Good afternoon, everyone. Hi. Good afternoon, everyone, and a very
afternoon.
welcome to all of you. Thank you for joining us, and we are really excited to have you for the third webinar of Glasstech Asia times PERAFI's series of webinars. If this is your first time with us, please let me introduce what this series of webinars are all about. So Glasstech Asia is delighted to collaborate with PERAFI, which is the Indonesian Facade Association, to produce this series of webinars which focuses on facades and its related building materials. The objective is to improve the quality of building facade industry through active discussions on key topics and content sharing from different international industry experts. These webinars are supported by BAO and BAO China, which are part of the BAO network organized by MMI Asia and Messe München. Before we move into the webinar proper, allow me to first introduce Glasstech Asia and PERAFI. Glasstech Asia, held together with Fenestration Asia, are annual exhibitions that focus on all things glass and are also known as the Glass Hub of Southeast Asia. Glasstech Asia is the leading BAO trade fair, while Fenestration Asia exhibits numerous products, services, and innovations from the window and door industries, as well as facade technologies. PERAFI, which is the Indonesia Facade Association, is an independent organization which seeks to grow the building facade industry by establishing sustainable business relationships and ensuring clear regulations and standards. Good afternoon to everyone once again. My name is Sarah Ang. I am the Director of Scenographic Design in Singapore, and I will be your MC and moderator for today. Thank you all for joining me. Today, we have an exciting lineup of speakers, and we'll be focusing on the topic of architectural sustainability. Now, what are the latest issues of concern and strategies to create sustainable building and infrastructure? On our wonderful panel of speakers, we have Mr. Joseph Lim from G Energy Global Private Limited.
Hi, nice to meet you all.
Hello.
Yeah.
Mr. Jose Claudio Silva from Ten Design.
Nice to meet you. Thank you.
Hi. Mr. Ferdinando Lucchesini from BSA Group Asia.
Good afternoon, everyone. Good to see you, Sarah.
Yes, good to see you. And Ms. Aviana Onasi from AGC Asia Pacific.
Hi, good afternoon, everyone.
Hi. All right, so after each presentation, we will be taking one quick question. And please send in your questions anytime during the presentation by typing it in the chat box. After all the presentations, we will then have an interactive discussion round, and we would like to invite all of you to raise questions and share your views on the topic then. Please note that we will be switching off your video and microphones. And before we start very soon, we would like to give a word of thanks to our sponsors, very important, AGC Asia Pacific and BSA Group. So a little about them first. AGC Group aims to continue being the first choice solution provider by offering unique materials and solutions. Their core technologies are in glass, chemicals, electronics, and ceramics. AGC Asia Pacific, AAP, is the regional headquarters of AGC Group and also one of the founding partners of the World Green Building Council's Asia Pacific Network. Caring for the environment is an integral part of the company's values, and AAP has since collaborated with green building councils in the network to help realize architectural sustainability and positive benefits of green buildings. For more information, you can visit them at agcasiapacific.com. BSA Group. So Intermec, a division of BSA Group, offers cutting-edge technology that meets the needs of operators who process glass, stone, and metal, with a full range of machining centers, water jet cutting systems, and sanders for machining operations of advanced materials. For more information, please visit them at intermec.com or their booth at Glasstech Asia, which will happen next year, 26 to 28 October at Marina Bay Sands, Singapore. Now, this is what we've been waiting for. Without further ado, I would now like to welcome our very first speaker to start us off on today's wonderful learning journey. Let's welcome Mr. Joseph Lim. He is the Chief Representative Indonesia of G Energy Global Private Limited, and he will be sharing with us about building envelope optimization to minimize external heat gain. Mr. Joseph has been with G Energy Global since 2007 and has since been deeply involved in energy-saving projects, promoting sustainability, helping clients obtain green building certification. Mr. Joseph is also a member of the Green Building Council Indonesia and is a certified green ship professional. So Mr. Joseph, please.
Okay, thank you very much, Sarah. Hi, everyone. Nice to see you all. Thanks for joining our webinar today. So please allow me to share the slide. Okay, so before we start, just want to check whether, are you able to see the slide now? Please confirm whether everyone can see the slide.
Yep.
Yes. Good.
Okay. Thanks for joining us, and also thank you for Glasstech Asia and PERAFI for arranging this webinar. Okay, so today I would like to share a bit regarding to the building envelope optimization, in order to reduce external heat gain. I think this topic quite important and also relevant to the topic today because being in the tropical country, I think quite crucial. How are we going to optimize our building envelope design in order to minimize the external heat gain? Okay, so basically when we talk about sustainable development, there are two things involved. The first one will be passive design optimization, and then followed by the active design solution. So when we talk about passive design optimization, this one will consist of a building basic, building orientation, opening sizes and location, and also building material selection. And then as for the active design solution, few things that must be considered carefully, such as the ACMV design optimization, equipment selection, heat water recovery, control strategy, and remote monitoring. So these two parts is really crucial and really important when we do a project, when we design a project. If we want to have a sustainable building, these two must be considered and designed carefully. So I will proceed to the next slide. So since we are going to talk about the building envelope, so actually there's correlation between building envelope and ETTV. In Singapore, the BCA under Green Mark, they already have a requirement for the ETTV, which is stand for envelope thermal transfer value. Basically, it's about calculating the facade performance. So we have to know what is the thermal property and also the design of the facade. Then from the parameter we have, we'll do the calculation. Then we'll have the amount of ETTV. So this is very important, very crucial during the design stage. So the purpose of, okay, sorry, this one a bit cover. I have to, hold on. Okay. So when we talk about the ETTV or envelope thermal transfer value, so actually there are three components of heat gain coming from outside. The first one will be from the heat conduction through opaque walls. And then the second will be heat conduction through the glass window. And the last one will be solar radiation through glass window. As I mentioned earlier, in Singapore, they already set a maximum standard, maximum permissible ETTV value, which should not be more than 50 watt per square meter. This ETTV actually will will have relationship with the building cooling load. If you have a higher ETTV value, meaning that your building will require more cooling load in order to make the indoor air more comfortable. So because of that, definitely the building will consume more power in order to make the cooling more comfort. So that's why ETTV is quite important and it's quite critical, especially for building in the tropical countries. So these are the formula of the ETTV. So basically, we have to calculate ETTV or each area orientation, and then we sum it together, and then we divide it by the area of the building envelope. So then later on, we can get the ETTV value of the total building. And then these are the detailed formula. So basically, this one will consist of the penetration area. We have to calculate the penetration area by using this formula, which is, we know now there's a few parameter like WWR, or stand for window to wall ratio. How big is the window to wall ratio? And then there's an opaque area as well. We have to calculate the ETTV value for the opaque area. And of course, some building envelope, they also design it with the shading. They use a vertical fin or horizontal fin, and also have some correction factor. So we also have to calculate for this area, this section. So after we have the entire calculation, and we put into this formula, then we can generate the ETTV value. Okay. So these are the sample of the ETTV calculation. Let's say if there's a building have 4 different orientation, normally have 4 different orientation. For instance, like a south orientation, east, north, and west. then we have to calculate the ETT value of each orientation. Yeah, once we know what is the value, then we multiply with the area of the surface, and then we divide it by the total area. So now we will get the ETT value is 48.15. Okay. And then what is the benefit of doing the building envelope optimization? I will give you some simple example. Let's say there's a 16-story office building. Yeah, this one, let's say under design. Okay. The GFA, let's say around 37,000. Yeah, with the office area, let's say around 34,000 square meter. So we have to differentiate, yeah, the type of opaque wall. You know, let's say they use concrete wall and also composite wall. And then for the glazing or for the fenestration, they use two types of glazing. The first one will be single glazing, and then followed by double glazing. So each glazing will have a different thermal property or U value. Yeah, in terms of U value, the lower the value is the merrier, because the U value with the lower thermal property will have ability to reduce the heat gain from outside. Yeah. So in this case, let's say they use two type of glass, and then we have to calculate each of the area for fenestration area, also each orientation, and also for the opaque wall. Yeah, and then after that we calculate. Yeah, so this is the base case calculation. So from here we can see for the fenestration area, they have the area of, let's say, 150 to 100 square meter. And then with the window to ratio, yeah, this one is quite high. Why I highlighted with the yellow color? Because this one actually considered quite high. Yeah, there's a possibility we can improve compared to the other, and especially some of them facing east and west orientation. Yeah, as we know that east and west orientation will contribute more heat gain. Yeah, although with this calculation, actually they already meet 50 watt per square meter, which is okay. And then in terms of the cooling load, if we convert, yeah, this building will require around 3,600 kilowatt, yeah, which is the heat gain coming from outside. Okay. How about if we are going to improve the building envelope? Let's say we do some improvement on the fenestration area. Yeah, we try to minimize it. Yeah, by minimize it, the fenestration area in from this highlighted color, then now we are able to reduce the ETT value to 34 watt per square meter. And the cooling load also will reduce. Yeah, from previously was 3,642, the heat gain from outside. Now we are able to reduce it to 3,161 kilowatt. Yeah, so this is a simple example. Yeah, so from here we can see the summary in terms of the ETT value will reduce by 32%. Okay, and then in terms of cooling load, we reduce by 13% compared to the base case. Yeah, the next slide I'm going to show you. This is our real project in Indonesia. It's a bank located in Serpong, Bank Central Asia office. So for this project, we involve as energy consultant to help them to optimize the building, not only on the passive design, including the active design. We also do optimization in terms of chiller system efficiency. So now I will elaborate more what we do for them in terms of the building facade. So these are the project team involved. The owner is a Bank Central Asia, the architect, yeah, we can see here, and G-Energy involved as energy consultant. Okay, so this building, the height is up to 64 meter with the gross floor area up to 47,000. So basically consists of 15 story. Yeah, so now we can see the building looks like the orientation, north orientation, south orientation. So in terms of the window to ratio for the north orientation, the total window to ratio is up to 44%. And then for the south orientation, the total window to ratio is up to 62%. Yeah, so this is the window to ratio. And for the west orientation, the window to ratio is up to 50%. Then for the east is even higher. Sometimes a bit difficult to to minimize the window to ratio, because in terms of architectural, they also have to consider aesthetic matter. Yeah, because the building looks not so nice if there's no any window or too less window, also not nice. So that's why they also have to compromise on this. So architect designed the window to ratio up to 59%. Yeah, for the east orientation. So these are the area. Okay, And these are the thermal property used. So basically, this is the material used for this wall. And for the glass, the good thing is they choose the glass with a good thermal property. We can see here the U value of the glass is 1.8, which is considered quite good. Yeah, and also the shearing coefficient also quite low, is a 0.24. Okay. And then they also apply the horizontal fin in order to minimize the heat gain, yeah, for certain area. Yeah, and this one they apply on the first floor, 8th floor partially, and also on the 15th floor. Okay. Okay, then after we have the parameter, we input the parameter into the formula, then we calculate. Yeah, this is regarding to the fin, and then overall we got the ETTV of 40.99 watt per square meter. If we compare to green mark requirement, actually this one is considered good already. In fact, this one can achieve green mark gold plus, yeah, in terms of the building envelope requirement, the ETTV value requirement. Because if I'm not mistaken, green mark gold plus in terms of ETTV must meet around 42. Yeah, so this building actually can meet 40.99, which is good. However, we try to improve further. Yeah, we also want to give them better result. So we have 3 recommendations for them in order to improve the ETTV. The first one by adding a parapet, 15 centimeters installation for each floor. Then by doing this, they are able to improve the ETTV to 39.59 watt per square meter. Then the second recommendation by adding a fin of 30 centimeters installation for each floor. By doing this, they are able to improve the ETTV to 40.77 watt per square meter. And then the third one, if we combine, both of them we combine together, and now they are able to improve the ETTV to 39.4 watt per square meter. So finally, after we gave 3 recommendations, 3 options, then client agreed to choose option number 3. So they are going to combine, adding a parapet and also fin together. So by doing this, they are able to improve the ETTV from 40.99 now become 39.4 watt per square meter. So I will show you what will happen if, because I've been in this industry since 2007, so I have seen many buildings in Indonesia, especially in Jakarta, yeah, especially for existing building. Yeah, in the olden day when they built the building, many of the existing building they use single glazing building. Yeah, many. Yeah, they used a single glazing type. So because of that, the ETTV value is quite high. In fact, if I'm not mistaken, in 2012, I did 2 projects. Yeah, these 2 projects actually is a new development. However, at the time, probably maybe not many people aware about the building envelope method. So when they build the building, when they design the envelope, they choose the single glazing. Yeah, and with the low, I mean, not so good thermal properties. Yeah, for the glazing. And then because of that, after we did the ETTV calculation, ended up we got the value up to 80 watt per square meter. Yeah, I'm talking about new building. This is not existing building. Yeah, the problem is at the time the developer a bit too late to engage us to help them to do the optimization. Yeah, so when they engage us, we calculate for them. Actually, they already bought the glass, they already installed the glass, they already put the facade, everything. So a bit too late to change. Yeah, so ended up we calculated the ETTV was 80 watt per square meter. Yeah, so now if I compare based on that condition, yeah, what will happen? Yeah, if we are able to reduce the ETTV value from 80 watt per square meter, now become 39.4 watt per square meter. Yeah, then the reduction will be around 40 watt per square meter, multiply the amount of facade. Yeah, I mean the surface of facade. Now we are able to reduce, yeah, in terms of the cooling load is around 98 ton refrigerant. This one actually equal to 14% of the total building cooling load of this building. Yeah, so probably maybe 14% looks maybe not so big. However, if we calculate in more detail, then we will be surprised to see the saving. Yeah, now I will calculate based on this 98 ton multiply by the system efficiency of the chiller. Let's say we base on 0.6 kilowatt per ton. Let's say because in this project we designed the chiller system efficiency to meet 0.6 kilowatt per ton. In fact, in reality, they are able to achieve 0.57 kilowatt per ton, which is better. So if you calculate with this efficiency multiplied by 10 hours, because this is an office building, so they operate for 5 days. So multiply by 5 days, then multiply by 52 weeks a year, then we will get the result of 154,000 kilowatt hours per annum. If we multiply with the electricity tariff in Indonesia, which is currently around 1,200 rupiah per kilowatt hours, this value will equal to 185 million rupiah per annum. Yeah, probably for you, especially in Singapore, you will see so many zeros, so many digits. Yeah, I mean, don't be surprised. In Indonesia, we have so many digits. So this amount actually is quite big. Yeah, with this amount, actually, you can buy a car in Indonesia, a simple car. Okay, so every year you can buy a car. Okay, and then if we calculate how much the initial cost saving, because they are able to reduce the cooling load up to almost 100 ton, right? So let's say 1 ton of chiller system equal to 15 million rupiah. So they are able to reduce up to 1.4 billion rupiah. Yeah, so we can see here actually the impact is quite significant. Yeah. Then how about if we calculate, we convert into the CO2 emission reduction, because now more people are aware about the CO2 emission reduction, right? So this energy saving per annum is equal to 112,000 kilograms CO2 per annum. Yeah, so I use the source from Bappenas. Bappenas basically is an Indonesia government body. So I use the conversion of 0.73. Okay. Then this amount of CO2 reduction is equal to 565 trees per annum can be offset. Yeah, so we can see here, seems like a small thing makes a big difference. Yeah, although looks small, but ended up makes a big difference. Yeah, so imagine every year, yeah, this building can offset the tree up to 565 trees per annum. Yeah, they can reduce the carbon emission up to 112,000 kilogram of CO2 per annum. If there are 10 building or even 100 building, yeah, apply or implement this, yeah, so we can imagine the impact will be very, very huge. So this is something that I want to share, why building envelope optimization is very important, very crucial, especially for us located in the tropical countries. Yeah, we need the light, we need the shine, but we don't need the heat. Yeah, so that's why we have to be careful when we design the building envelope. So my suggestion, please, yeah, please select the thermal property, the glazing with the better thermal property value in order to reduce your heat gain. Yeah, because once you install glazing with a high thermal property, then in the long run, yeah, the building will suffer in terms of the energy efficiency, in terms of the operating cost. Yeah, every year they will lose money. Okay. Okay, that's about the case study that I'm going to share. The next one will be a bit introduction about our company, so I will try to make it fast. As I mentioned earlier, I'm from G Energy Global, so we are accredited energy service company in Singapore. We are also as an ESD consultant. Okay, these are our company mission and vision. G Energy Global established in Singapore in 2005, and so far we have set up few offices in Jakarta, Malaysia, and Shanghai. We also have a strategic partner in Guangzhou and Philippines, and our project located in the Asian country like Indonesia, Malaysia, Thailand, Singapore, Brunei, Cambodia. So those are our projects. So these are our company services. We provide energy audit. We also provide energy optimization for the new development, project management and energy consultancy, green building certification like Green Mark, Green Shape, or LEED, BEAM and simulation, utility supply contract, building management system with remote monitoring. We also provide air conditioning services and repair, and then monitoring, evaluation, addition, alteration, and turnkey project. Okay, so what we do as a consultant, we always believe in performance-based solution. Yeah, so we will start with the conceptualization, and then we'll do the calculation, simulate, materialization, verification, and finally will be digitization. So this is our approach, yeah, to our client. Okay, so basically building performance, there are two things, yeah, prescriptive and performance-based. So we always believe in the performance-based. At the end of the day, we have to prove to client whatever the targeted system efficiency can be achieved, can be met. So that's why we always based on the performance. Okay. From 2005 until now, we try to calculate how much energy saved, yeah, from our project. So up to now, we have actually contributed, yeah, to reduce the carbon emission up to 978 million kilogram per annum. This amount actually equal to 4.8 million trees we can save. Then if we convert into US dollar, this value actually equal to accumulated saving, yeah, up to 450 million per annum. So I think in terms of amount, I think quite significant, yeah, to our client and also to our environment. Okay, these are some of our work experience. Yeah, so we do, as I mentioned earlier, we do measurement verification. Yeah, this is when we do the audit for the chiller plant. We log the data. And these are the sample of our simulation work. So we can do sunpad analysis. These are one of the job that we do solar installation analysis for Keppel Tower in Singapore. And then solar study, daylight and glare analysis, sunpad analysis, wind-driven rain analysis. We also can do CFD analysis, rooftop cooling tower CFD analysis, energy modeling. For some project require energy modeling, and actually energy modeling is quite important as well. Before you finish the design, during design stage, actually you can estimate, yeah, before your building done, yeah, how much the energy will be consumed by the building. So we can do the simulation through this energy modeling. This one of the project, Ng Tong Feng General Hospital. So for this project, we design in such a way that every ward no need to use aircon. So basically, they will utilize the natural ventilation. Yeah, so you can see here the design layout of the ward is quite unique. So every bed they will have their own window to allow a natural ventilation to give them more fresh air. Yeah. And this one, the facade optimization. Even for this project, we are able to achieve overall LTPV of 36.64 watt per square meter. Okay, daylighting and glare analysis and control, shading optimization. This is another solution in order to improve your LTPV value. You also can implement the shading to minimize the heat gain. And also this one, the air ventilation or CFD. When we talk about green building, also related to the water efficiency, we also can give recommendation to our client how to reduce the water consumption. And also in terms of landscaping, how to optimize the green plot ratio. These are our project in Singapore, some of our projects in Singapore. Okay, some of our projects in Singapore. We also do Jewel, Samuel, Westgate. Okay, when we receive award as first private owned positive energy. Okay. Okay, one of our project is a City Square Mall. This City Square Mall considered as the first Green Mark Platinum for mall in Singapore. This project done in 2008. And then Green Mark District. We also provide control system. Okay, and then this one, the project in Johor, Forest City Island. Here is another project. And in Indonesia, we have done several building in Indonesia. Lastly, one of our project just got the Green Mark certified in Medan. Here, Delhi Park Mall in Medan. So this mall actually is the first Green Mark certified for mall in Medan. Yeah. And then Sinama Slam Plaza, also our project, they got the Green Mark Gold Plus, BCF Foresta, yeah. And then Tamrinan Office Tower, Plaza Indonesia. These are some of our projects in Indonesia. Okay, our company also received 3 awards, yeah, in 2009, 2012, and 2015 from Frost & Sullivan as Best ESCO of the Year for Southeast Asia. These are our company milestone. Okay, so in 2018, G-Energy also received award as an Energy Service Company of the Year. Okay. Okay, so that will be my last slide. Thanks, Sarah, for giving me time. So probably maybe any question from participant regarding to my sharing session this afternoon.
All right. Thank you, Mr. Yusuf.
I hope I don't speak too fast. I hope, yeah, hopefully not too fast.
No, you did very well. Thank you very much. Thank you for the very detailed presentation, Mr. Yusuf. It really gave us a deep insight into the huge energy savings that you can get just by carefully evaluating the different elements that you had shared in the building envelope. So they're very significant impact that you can get. So in the interest of time, we would like to save the questions for your segment at the end. So we will move on to the next speaker. So thank you again, Mr. Yusuf. And we would now like to welcome Mr. Jose Claudio Silva, Design Partner of 10 Design, and he will be speaking on architecture, culture, and sustainability. Mr. Jose has over 18 years of design and delivery experience with his design and master planning expertise spanning a wide spectrum of sectors, including mixed use, hospitality, civic, office, retail, residential, MICE, and integrated resorts. And a selection of his award-winning projects consists of Sky Park at Marina Bay Sands, Singapore, Global Tech Exchange in Phnom Penh, Noble House, and World Capital Tower in Jakarta, among many others. Mr. Jose, please.
Thank you very much for the invitation. I would like to share my screen. Yeah, now I have the option. Can I just confirm that you can see the screen?
Yes.
Okay. So again, first of all, thank you very much for inviting me and 10 Design to participate in this conference. Thank you for the sponsors and the organizers. I'd like to start, first of all, with a small introduction about the company. And then I'll go through the theme that I propose to present today. So 10 Design was founded in 2010, so it's a relatively new company, young company, let's say. We have more than 200 architects throughout the world, and we are truly a global company where we share knowledge, we share resources, and we participate as a full team throughout the world. At the moment, we have 4 design studios. There's Hong Kong, Edinburgh, Miami, and Singapore, and a few other offices around the world. But we share the resources, and we may participate in different projects from different design studios at the same time. So today, so Singapore office, and today I'm quite introducing the office. Is the first conference we participate from the inception of the office. The office has about 6 months old, so everything that I'm going to speak today will be ongoing projects, so and very recent and ongoing projects. So nothing is finalized yet. So that's a little bit of a different character of conference that I've ever done in my professional life. So just again a bit back to 10 Design. Although we are a relatively young company, we are very proud of our portfolio of awards and considered one of the top 100 companies in the world, architectural companies, with several awards, and we are very proud of it. We don't design for awards, but we design. Each project is one project. Each project has its own process, its own character, and it's designed to be unique, to bring something new to the environment and to the context where we propose to design. We have several sectors, let's say, from master planning, architecture, from mid-rise, low-rise to high-rise. We have landscape design, in-house landscape. We have a CGI team that is specialized for our own buildings, let's say, to control also the graphics and the way that we communicate our buildings. And also, which is important for today, sustainable research is part of our process for conceiving architecture. So now a bit finally back to today's theme, architecture, culture, and sustainability. So I'll present a couple of projects that are ongoing. So several details I can't really release, but I will be more than pleased to go through the process, where we are in each one of the projects and what we are doing to provide the best project and best building performance, taking into account the sustainability, of course, as an underpin to all the projects. So the first project we have been involved here in Singapore actually was a project in Tanzania, Dar es Salaam. So as mentioned before by the previous speaker, part of the environmental measures we did here was really to use passive environmental design, shading to minimize the heat gain of the facades. So this is part of our way of interpreting the environmental design or sustainable design, let's say, that there's a component of environmental conscious design. There's a component of culturally sustainable, adequate, and that brings not only the part of some link to the culture itself of the country, but also the culture in construction. What is available, what is adequate to detail, what is adequate to bring to the project to design with. So this project is a mixed-use development with service apartments on the top part of the project, hotel and office, and car parking podium. So it has a total mixed use. It's in an area of Dar es Salaam that is pretty much, there isn't much buildings beyond 4 or 5 floors. It's oriented, it's quite a square site fronting the main road at north. And the exposure, let's say the solar exposure is pretty much, it's the location of the Dar es Salaam is pretty much in the equator, so it's not too different from Singapore, the solar let's say dynamics, and so we had to be particularly careful with exposure to east and west, of course. So in terms of wind, the wind diagram that we have is prevalent winds from southeast, so something that could be brought to the design as well if we could explore that. So our approach was really to bring a bit of we did some simulation of just proofing in a computerized way about what would be the best exposure to the building if what we were providing was adequate to the site, adequate to the exposure to east and west sun. Particularly west would be more delicate to deal with. But again, as mentioning before, part of our sustainable design has to do with the culture and what is available in the industry, what is familiar in the industry, what we can bring to the building and the building performance, not over designing or designing with some elements that are not common or very difficult to implement on site. So here we really wanted to bring shades, very let's say off the shelf kind of materials, nothing too high tech, and work with the shades of the provided by the balconies and some additional elements really to bring a passive environmental design and a good performance to the building, and protect as much as we could the heat gain from the facade. So we also wanted to bring this green, lush environment to the building, and each one of the apartments has this kind of sky garden or sky terrace, garden terrace, that also contributes not only to have like a more lush environment, but also protection to the solar heat gain through the windows. So it's a pretty it's a complex building in the sense that there's a compact site with mixed-use development. So this is still ongoing. We are really detailing, proofing and testing the facade and the solar protection that we can bring with these shades, and really keeping the building as low tech as possible, due to also to accessibility to high tech construction and so on. But and also be conscious about the cost of construction and what could be sustainable for the client and for this building. This second project is a large master plan, is still ongoing. It's still in a very preliminary stage. We were commissioned to do this project is a master plan in the water frontage, sea frontage, somewhere off the coast of Vietnam in Cambodia. So we completed a master plan stage. It's a project that, I mean, there isn't, of course, we need to be very careful with the exposure and the solar heat gain. But in fact, the whole project is facing west, and in the Southeast Asia, it's definitely an issue. But there is no other way that we could go against this exposure. So it's really fronting the sunset, fronting the beach. So this prevails in terms of the value of the project, of the let's say the properties, but also our main intention was really to provide whoever is going to live in this place, provide sea view, the sunset view, the beachfront view, enjoy this very peculiar and very dramatic and beautiful scenery that we have with the sea. So these images are from a master plan stage. So there's some villas fronting the beach, some service apartments and condo hotels just behind the villas. So trying to maximize beach view and sea view from all the units, all the components of the master plan. This is an overall view from a day club that is located in a rocky promontory of the site in the south, that has this dramatic view through to the bay, let's say, and the hotel at north, and the service apartments and all that in the back of the villas. You can see the villas as well. These ones, they front, let's say, a little cliff. The other villas front the beach, which is public, so can be accessed from anyone that lives or is in this development. This development is planned to, again, in a very another conditioning to the way that we were planning. The client wants a very iconic building, but this location is relatively remote, isolated, so very difficult to bring let's say materials and to have a sophisticated construction, as everything has to be brought by sea. And also the whole master plan is thought to be operated, let's say, not by normal cars, but only by small buggies. So even all the construction, has to take into account this level of this desire from the client, this approach to this development. So combining things, it's relatively a challenge for us, and it has been a little challenge. So this is again just to show the solar analysis to the site. Again, the whole site is really exposed to the is west facing, which is fantastic. It's a sunset view. It's beautiful for a resort master plan and the character that we want to have in this site. However, it poses some challenges in terms of how to deal with heat gain, facade heat gain, and so on. So as mentioned, this is ongoing project. We wanted to bring a diversity to the site and bring some different components, different approaches to the concept of this site. So one of them was to have a nautical kind of theme, exploring the white massing, ropes, the sails, the let's say the palette of materials that you can easily find in sailing boats in really nautical theme. This we were proposing to have for the buildings that were really facing the sea, facing all the villas and the iconic building at north, which would have a hotel component and a marina as well. Another theme would be a tropical modern. This was something that we were envisaging to be more into the buildings that were facing the mountain. So in close relationship with that green and lush that is present just in the back of the site. And then something that we called Vietnam Memoirs, which will be a bit more inspired with Vietnam vernacular architecture. So from there, for this component, we'll have the promontory in the south and also commercial nodes that we have in the center of the site, which will be the prevalent access, public access to the beach. So moving forward and just concentrating two of the components of the site. One of them is really the iconic building. We wanted, the client wanted to explore the sail theme on the back of our proposal to have like a nautical theme to the architecture that is fronting the sea. We wanted to have a very close relationship with the green mountain as well. So very, very lush, as we say. And so this presentation, again, it's very much into approaching our concept stage. We wanted to bring to bring this gesture, a bold gesture and iconic to the building itself, but also try to plan the shades and the depth of the balconies and the distance between the balconies and the edge of the building, the facade, the glazed facade, to be sufficient that we could be comfortable. We would have comfort inside and not relying exclusively in the air conditioning. So to minimize the air conditioning load, so to have really an environmental passive design to very adequate to this zone. So we tried to, again, we are trying to design something that can still be iconic and very sensitive to the location and to the exposure to mainly to west facing, which is what we want to have. Is we want to have the building facing the sunset, facing the sea, but also to have a certain level of sustainable design. So we are trying to design these fins, let's say horizontal fins, these balconies that have at least 1 meter depth for let's say comfort or use from each room, and 1 more meter that would address the in a certain extent aesthetics, but and also address to the full shading of the balcony through west facing. So this is aggregate solar heat gain analysis for the overall facade facing the sea. So we can see that this is without the fin, so something that we have the, that's like the proof that we really needed. So, but bringing more scientific kind of analysis, more computerized analysis, and then trying to introduce gradually the shades, the balconies, and to see what could we do, what could we achieve with the balcony. So how could we reduce the heat gain to the glazed facade, and progressively bringing it to a level that aesthetically we wanted, that we are still testing, but aesthetically we would be comfortable with it, and also in terms of performance to reduce the heat gain as much as we could. And you can see this last diagram, the whole facade, even facing the west and facing the sunset, so low sun and so on, with these shades, we would be very comfortable with reducing the solar heat gain to the minimum we could. So then it's a matter as well, keep testing so that we are again confident and comfortable with the aesthetics of the building that we are creating, but also that in terms of performance we are achieving something that is operation wise and for the initial capital cost from the client also sustainable in that sense. So we are still in an optioneering kind of time, and we wanted to explore. We are still exploring this sale theme. One of them was kind of a let's call it an international sale, a more common sale. The other one is a more linked to a cultural sale, let's say a local sale that is common in Vietnam and that Indochina region. So we wanted to bring that design of the sale to the hotel, also to bring us a little bit of a different planning approach. So it's a very much more rectilinear kind of volumes that would bring a certain level of efficiency to the operation and so on. But fundamentally, two different approaches that we can explore a bit further to see the benefits of one and another. In terms of exposure, this one is definitely easier to achieve a better performance. Let's say it's naturally the building is facing north and south, so it explores really the view to the beachfront, to the beach itself, the bay, and also to the sea at north. So it's really a dramatic exposure. And then the service apartments and condotels, which we are not, we haven't yet tested the facade, but just to show where we are today, the idea was really to bring that lush and depth, some depth from the strong lines of facade to the glazing. You can see that there's a certain depth in that facade, and trying to bring the greens as if the mountain was kind of taking over the building, as if the building had been part of that, like part of some sort of symbiosis with the mountain, something like that. So we are still testing things. Right now, we are trying to we develop the building look itself. Now we are looking into getting the performance, the testing, and the modeling of what is the performance of the building as we have right now. We don't have the results yet, but we are assuming. So these carved balconies, I think they could be potentially well in terms of performance and exposure of the glass. There's some areas that we definitely need to look into introducing some screens or some other areas where maybe the balconies need to start protruding out a bit more to get that depth that we were looking into having. But again, it's a building that is very lush, bringing that the mountain to the building itself, and several screens, several ways of passively controlling the the heat gain in the facade, and also having this exploring this west-facing fantastic views to the beach front and to the sea front as well. So this is where we are. This is something that I mean, very peculiar presentation for myself because of, again, the character of where we are today in the TEN Design office here in Singapore, servicing Southeast Asia projects, but also some in the Middle East, and contributing for the whole family of TEN Design to keep great design and great sustainable responsibility in whatever we do. So this is what we have for today. Again, just a more detailed approach, and this is it for today's presentation. So thank you very much for the opportunity, and looking forward to hearing from you your questions and feedback.
Thank you, Mr. Jose. Thank you for presenting from a design perspective on how we can look at achieving architectural sustainability, but also bearing in mind that it still has to look very beautiful. And in your projects, we've seen a lot of that, maintaining that balance. Thanks for sharing with us your very beautiful work and how you take inspiration from the culture, the locale of the place, and also maintaining sensitivity to what is you consider already familiar and already available to the country. So we will have questions at the end of all the presentations, and we would like to move on to our third speaker. So we are very happy to now invite Mr. Ferdinando Luchesini, Sales Manager of BSA Group. He will be sharing with us about smart processes as an enabling factor of architectural sustainability. Mr. Ferdinando has more than 25 years experience in Asian markets, including China, India, and Middle East, and is passionate about advising clients on how to expand and improve their production capabilities in order to create a seamless processing flow in their factories. Mr. Ferdinando, please.
Thank you. I hope you can hear me well. And okay, we got the presentation, which, sorry about that, is driven directly from the organization, because there is a little bit of problem with the connection. At the moment, we are in Malaysia, we are in lockdown, so I can't work from the office. Anyway, long story short, thanks for inviting me to this interesting session. And let's move forward one by one, the slides. Okay, my name, my difficult name is Ferdinando Luchesini. I'm Italian. I'm from the Malaysian subsidiary of BS Company, which is an Italian company with over 50 years of woodworking machinery knowledge, whose Glass and Stone division, Glass and Stone department, is the Intermac brand name, which also has, it's not as old as BS, but it's also more than 30 years old. And today we're talking about the role of smart glass processing in connection with architectural sustainability. Okay, next slide. We are not architects, as a matter of fact, but with over 30 years of experience in machinery manufacturing for processing glass, we can help to turn ideas into projects. And the chain of knowledge is what we have seen until now. We started with Joseph Lim, who talked about design parameter, who talk about concept on how to build sustainable buildings, and we move them to Jose, who talk about ideas from the architect point of view, and now we delve into something a little bit more on the works side, on the practical side. We will hear later on AGC talking about materials. We will talk about machinery. And we can move forward. Sustainable architecture is a concept behind the accomplishment of green buildings, whose main features are to be nature-friendly while caring about the dweller's comfort and being all-round cost-efficient. Driving factors to raise green buildings are energy saving, to avoid polluting the environment, and a better quality of life. These targets are achieved with an extensive use of natural or recyclable materials. And we know that glass is one of them, is a pretty much recyclable material. Helped also by renewable energies like solar and wind power and an efficient water management. Next. Here in this slide, we can see a few examples of green buildings around the world. I'm sure that my colleagues who held the webinar before me are much more competent and much more knowledgeable than me to talk about them. But here we have a few examples. Federal Center South Building in Seattle, which has actually gained a 100% score in the Energy Star as a real net zero energy building. Then we have the Park Royal on Pickering Hotel in Singapore, which is a hotel in a garden concept and is also award winner for the sustainable project design and the use of solar energy system. Then we have the San Francisco Public Utility Commission headquarters in San Francisco, in California, and this one is a real energy saver. Imagine that the full structural glazing that is surrounding the building helps to trim the energy bill by 45%, and the wastewater management alone cuts the water consumption by 60%. Then we have the Bahrain World Trade Center in Manama. It's a pretty unusual application. This one, as a matter of fact, is the first twin skyscrapers in the world with their own wind turbines installed on 3 sky bridges. And the 3 turbines deliver a total of 675 kilowatts of wind power energy. That's a lot of energy. And last one, well, homage to Italy, to my and my company's homeland, the Bosco Verticale, meaning the vertical forest in Milan, which is a daring urban reforestation project concentrating in 3,000 square meters of surface the trees of a 30,000 square meter forest. With natural oxygen production and CO2 absorption, is contributing to the environment and also to the well-being of the dwellers. And it's considered today one of the most iconic buildings, at least in Europe, if not in the world. And let's move forward and talk about the application of glass in the green buildings. Glass has an important role in the building industry, especially so when we talk about green buildings. The main application are, we see glass more or less everywhere in a building. Structural facade with double glazing and low E glass, fenestration with double or triple glazing, low E laminated glass. Triple glazing is something that is more common in Europe, but it will come. Skylights, obviously all laminated glass, balustrade and railing also with tempered laminated glass or simply laminated glass without tempering, and the photovoltaic solar panels, which is made with a kind of special kind of glass. It's called the ultra clear low iron glass. More importantly, these are the benefits of the value-added glass that we mentioned. A wider glass surface for a natural ambient lighting, a high-performance facade for better heat and sound insulation, the glass roofing, again, for natural lighting, safe covering and power saving, the balustrade for a protected but transparent view, and the PV solar panels, which are, as a matter of fact, energy generators. Next one, the demand from, moving a little bit slowly, okay, in pursuit of the best. What does it mean? It means seen from the perspective of the builder. What does a builder expect from his glass supplier? These are the 4 key expectations. The quality, which means accuracy, repeatability, flawless production. The punctuality with automation, cutting idle times and fulfilling scheduled plans. Customization, thanks to flexible machines capable of working on small batches and on-the-spot samples without affecting the productivity, and obviously a competitive price, which is always welcome, coming from an efficient production, which is a saving time, material, and so money. These points are all driving towards one direction: process automation, the best practice to grant a perfect all-round service to the builders. Next one. And what are the features that make a factory a smart manufacturing hub? These are the 6 points. The machines are no more standalone items, but they form an integrated, seamless flow of production. They exchange data and communicate to each other. There is a supervisor which controls productivity, quality, efficiency, and provides statistics. And supervisor is not meaning a man, it's meaning a software. Machines are online, performance and status can be remotely checked at any given times. The processing flow is the fastest with the least human intervention, and machines are equipped with predictive maintenance software for a hassle-free and reliable operation. Next. So we talk about this value-added glass, like insulated glass unit, like laminated glass, like tempered glass, but all these high-value glasses, to produce them, it all starts from the pre-processing. And this is Intermac focus and know-how. With our range of handling and loading systems, float and laminated glass cutting, seaming, edging, polishing, working centers, water jets, and washing machines. Giving the right importance to the whole processing cycle is what makes a glazing business successful, and Intermac is here to help each customer to do so. Next one, and we will go step by step through the processing line. First task when the glass arrive in the factory is to unload them. They are large blocks, they are weighing some tons, they are hauled around and stored for future use manually. Manually handling glass of such weight and size is difficult, dangerous, and time-consuming, and can even result in costly mishaps. Glass, let's not forget, is a fragile, is an easily breakable material. Minimizing this operation saves time, money, and staff precious health. The solution lies in the range of automatic stock selection systems by Movetro, from manual handling to Movetro solutions. Movetro is a company of the BS Group and has the widest range of storing and handling machine fitting the space, production, and budget that each customer may have. The main benefits of this solution are all the stock can be readily available for cutting. No more double handling of the glass packs or sheets with all the related risk factor, and this is particularly appreciated by customers. The possibility to restore and reuse the half plates that haven't been fully used, and the modular concept of the solutions which allow the stock area to grow in the future with the growth of the company and the production increase. Next one, we will have a look at the different, if not all of them, but some of the most common solutions provided by Movetro. These are called telescopic loaders. They are single sheets mover. It's meaning that they pick up one sheet at a time. They are a compact solution. As you can see, there is a certain set in the back of the picture of different kind of glass that can be picked up. They are all available for pickup. There is an arm, which is sliding inside the stock with suction cups. It's picking up one sheet at a time, tilting it down and sending it to the cutting table. It's a flexible production because every second sheet can be different from the previous one, but nevertheless, it's a productive one. It delivers up to 150 sheets in one shift. It can feed 1 or 2 lines according to what is the size of the lines and what kind of production they do. It can be easily expanded, and it has as options also the possibility to manage the half sheet, to return the half sheet to the stock, and even move glass from one rack to the other. Next one. We still stay in the single sheet movers, but you can see that this machine looks pretty big compared to the previous one. You can see that the stock is much wider. These are called gantry loaders. These gantry loaders, they are able to deliver up to 200 sheets. In terms of stock, we may say the sky is the limit, because we have customers who have made stock with 100 and even 150 positions, 150 different kind of glass stored in their factory. We have examples in US, in South America, in Europe. They can feed obviously multiple cutting lines. They have an interesting pass-through cycle to handle the low E, soft-coated low E glass, which brings us back to the green building theme, because the soft-coated low E glass is one of the glasses with the best U factor, and this is meaning that it's very good for insulating inside from outside. It can have the track offloading. I will explain to you later what it is when we talk about the next one. And again, remnant management and rack-to-rack are also a given in this solution here. Next one is a different concept. Next slide, talk about pack movers. What is the difference between the previous ones and this? The fact that the glass is not anymore managed one sheet at a time, but one pack of glass at a time. It's meaning that this machine that we see in the middle of the picture, the one that is running on rails, like a small train, is actually capable of loading a rack with a pack of glass on top and delivering that to a cutting line. The productivity is the highest. We're talking about up to 300 sheets in a shift for each cutting line that is feeding. Just to give an idea, to not everyone is familiar with the ratio between sheets and size, we're talking about over 5,000 square meters of glass to be cut in a sheet. In a shift, sorry. It feeds multiple cutting lines. It has a maximum payload per square meter, and again, remnant management, rack to rack, and the capability, which is a feature exclusive to this solution, of refilling the stock as it works without having to stop the line, for the simple reason that the refilling, when the truck is coming from outside and delivering a pack of glass, this pack of glass is loaded outside the fenced area, the safety area where the machine is working, and it will go and pick it up and send it to its position when it's done with the other mission. So it can work 100% of its time without any single interruption by refilling the stock in total safety. So we can say in a nutshell, Movetra has a tailor-made solution for each and every production needs. Next slide. Okay, from loading to cutting. The next step is to cut the glass. We have a big sheet of glass. It has to be cut into pieces that will soon be processed, transformed in high-value glass, in added-value glass, which will go into the green building. So, as a matter of fact, the cutting table is nothing new on the market. Cutting table has been around for decades. But the Intermac cutting tables, they offer some exclusive and patented feature, like the automatic cutting wheel selection for the perfect score in any condition, straight cut, shape cut, thin glass, thick glass, without having to replace them manually, which is a loss of production. And today they are actually really multifunctional machine, because we can see in the other picture two other functions which are important specifically for our talk about green building, and not only. The edge delation of soft-coated low E glass for IGU. Edge deletion is something that is required in order to remove a coating, which improves the U value of the glass. But at the same time, if you don't remove it, it wouldn't allow to make a IG unit which stays together, which sticks together for 10 or 20 or 30 years. That is the expected lifetime of an IGU. So in order to do that, you need to remove this coating, this metal coating that there is on the surface of the glass, and this is the right way to do it. Then we have the glass labeling. Glass labeling doesn't refer necessarily only to the green building, but it refers to the better, or I would say the best practice of production. Because if you can label each piece while you're cutting it, this will be a piece that can be tracked down through all the production line of the glacier and can even supply some useful information later on to the customer. It has a QR code, can be printed with a QR code, which is not only important to know what glass is that, but even to automatically tell the next machine what they have to do. It carries all the information to adjust the other machines without having the operator to do that. What does it mean? Less mistakes, less wasted glass, less production time increase because of errors. Next one, I would like to focus a little bit on the laminated glass for a simple reason. The laminated glass is one of the best examples of safety glass, and there is definitely quite a certain amount of laminated glass around buildings. Specifically in a building, you can see some examples, some pictures. There is laminated glass, obviously, in the skylights. There is laminated glass for the same obvious reason also on balustrade. The balustrade must be something that if a kid with a tricycle hits the glass, it doesn't allow him to fall off for a simple reason that the laminated glass stays together. It doesn't crack and falls like tempered glass, but it stays together. Staircases, railing, balustrades, balconies, glass flooring, curtain walls. There's so many examples of laminated in a building. So Lamiglass, I don't need to explain probably anybody how a laminated glass is done, but in reality, as we can see in the picture, it's made of 2 or more, even 3, 4, depending on the level of security you want to have from the laminated glass. 2, 3, 4 layers of glass interleaved with some plastic, transparent plastic, typically it's called PVB, but there are other solutions too, which allow the glass to stick together when it gets broken. So it's good for safety, it's good for security, but not only. Another main feature of the laminated glass is that it is a sound dampener. The plastic inside acts as a dampener of the sound, so it's good for insulation from the outer noise inside the building. And it's also, last but not least, good for the UV rays. Okay, so now from material to how to process this material. In Southeast Asia, we have to say that the use of laminated glass is not as big as in other parts of the world, or at least there is laminated glass, but it's not processed so frequently as it is, for example, in Europe, for a simple reason, that there is not yet a huge demand of laminated glass. In Europe, just to give you an idea, IGUs are, we would say, almost completely, for new buildings, we're talking, almost completely made with laminated glass, 2 panes of laminated glass instead of 2 panes of float glass. So this is meaning that there is a massive demand of laminated glass. The proportion between laminated and float glass is 80 to 20. Most likely here in Asia, especially in South, the proportion is the opposite. It's 80% float, 20% laminated, if we are lucky. But it's coming. I can tell you that it's coming. How does it work in Europe? In Europe, the laminated glass is manufactured, not custom laminated, piece by piece, glued together piece by piece, with a lot of time wasted, with a lot of energy wasted in the autoclave because you are producing small panels instead of big sheets. In Europe, it's produced by sheets, jumbo, regular sheets that are cut to size by machines like the one that we see in this slide. Machines which are capable of scoring the two sides of the glass at the same time to create an automatic cycle so that the two sides of the glass are not only scored, but they are also open. There is also the breakout. Then there is a PVB heating, melting, and then the separation of the two pieces, which is granting a productivity and allowing the glazier to complete orders of lamy glass, not in days, but in hours, starting from the big sheet. The range, as you can see, there are three examples. The range is from the basic machine, the standalone machine, single table, which is suitable for a customer who wants to delve into this kind of technology with a reasonable budget, to the more technological cutting line, the one in the middle, which has added features like plate and sheet rotation, automatic piece alignment, and the innovative, which is something to breakthrough, cutting shape cycle for laminated glass. Until recently, the laminated glass by machines could only be cut with straight lines, not in shape. Now it's possible also to do shaped cuts on laminated glass. If you want to do a domed window, you can do it. Finally, space saving, you got the combi line. The combi line is a combination of two different technologies, cutting float glass and cutting laminated glass in the space that the line in the middle is taking. So practically it's a very space efficient solution for customers who want to be able to cut laminated and float glass. Again, the combi line is still more popular in Europe than any other place in the world. Again, for the simple reason that is cut 80 to 20, the proportion. Okay, we can move forward and talk to what comes next. The automation is a trend that is becoming important in all the phases of the glass factory. After cutting the glass, an edge must be processed with different level of finish according to the application and the kind of value-added glass that is going to be used in. Laminated glass will require a different level compared to IGUs, and tempered glass, depending if it is framed or not, will require different edge work. Our CNC can work pieces in shape or can process additional jobs like drilling holes in the glass, making cutouts, for example, for making doors where there is holes for the handles, or what they call in a common language of the glass, the Mickey Mouse for the hinges and so on. Or they can also make some other particular, peculiar processing like the surface engraving, the face of the glass engraving for decorative purpose, or also beveling of the edge still for decorative purpose. All of these can be done with the CNC working centers of Intermac, which actually in this field is really considered a market leader. Intermac was the first company in the world who invented the CNC working center for glass processing. So we are still the market leader, and we are innovator because we are studying new solution every day. The robotic cells, that's where we come about to the title. The robotic cells are making the automation into this machinery. A single robot can serve one or two machines, and the deployment of a robot can grant a long list of benefits compared to the manual loading, which is 90% of the way customers are loading the glass into their CNCs. And the benefits are reducing the operating costs, improving the product quality and consistency, raising obviously the daily output because the robot can work 16 hours without interruption, saving factory space, complying with safety regulations, and avoiding, also important, the human factor errors. Okay, having talked about the process, we may give an example with the next slide of a layout of factory integration. Example of factory integration. In this example, which is not simply something which is on the paper, we have all the machines which become a seamless solution from machines to solution, allowing a smooth flow of the glass pieces, satisfying the targets that were declared by the company owner, which were two simple words: only in line and no more glass touched. He expressed this wish, Intermac delivered. Right to left, we have a Movetro shuttle system with 70 stock positions, 70 jumbo stock positions, two cutting lines, one above and one below, both for monolithic and laminated glass, so they are flexible and they can both cut both kind of glass. There is a conveyor on the bottom, the gray one, 15, 10, 12, you see that point. This conveyor is delivering the glass to two robots, which in turn, according to the kind of job, pick and load the piece and send it either to a horizontal working center or to a double-edger, the number 16, which is polishing, grinding and polishing all four sides of a square glass in one single fast cycle. The other cutting line, the upper one, is number 5, is delivering the glass to a very flexible vertical working center, which is number 6 and 7. 7 is actually the loader, its own loader, which is giving the maximum automation, but a lot of flexibility. This is the remarkable display of technology that we are going to see in the next and final slide, where we will see the clip of this customer who is called Toulard de Verre, and it's a French customer who has entrusted the Intermac to his full glass operation. This is Mr. Glumineau, the CEO of the company. Sorry, the whole video is shot in French because they speak French, but it is showing pretty much is a subtitle in English for you to see and understand. This was the area of the stock. He said that in 2008, they wanted to realize this fully automatic line. Here we can see not one, but the two robots. They are dealing with different kind of production. They are dealing with decorative items. They are dealing with architects who require special, colorful pieces of glass with nice motifs, which are made through a silk printing machine, a digital printing machine, which is turning glass into art, like these examples here. These are all panels of glass printed digitally by a machine that they have. And all these final products for architectural purposes, they were done through this input. Nothing touched by a man, and every machine in line with the other. Here we can see the robot picking up glass and delivering to the CNC, to the horizontal CNC. This is Mr. Piscina, who is the managing director of the company, and he was the one who directly dealt with Movetro and with Intermac to create this solution. This is the shuttle which is carrying the glass to, you see, this is a panel of 6 by 3 meter of glass laminated, which is going through the laminate cutting machine, a very automatic machine which can deliver pieces, as I said, in hours, not in days. The challenge was not to touch the glass, and the challenge was to have a full control of the production. And we managed to achieve both of them by means of a solution which has been put down in more or less 1 year from the very day we started the project to the delivery of the full system fully working. No more, as you have seen before, what they didn't want is to have a man carrying around a big sheet of glass around, hanging from a clamp, dangerous, difficult to move around, risk of hitting anywhere, breaking the glass, hurting somebody. All of them is a history for EEV because they managed to get all this system fully automated, fully functional. Now, we will see that this is not only automation, but it is also very space efficient. If you have seen the layout, there was practically no space wasted around the machine because there is nobody who has to walk around the machine doing some work. The machine can be as close as possible and need to be as close as possible to save on factory space, which doesn't come free, and at the same time allow to bring in an ordered flow the final pieces that we see here already on the rack to be sent on the market. And this is just them saying that with the cooperation with us, we managed to make this kind of dream come true. This comes to the end of my presentation. I thank you all for the attention, and I pass back the word to Sarah. Thank you.
Thank you, Mr. Ferdinando, for the wonderful presentation. Yeah, thanks for showing us how it is possible to fully automate manufacturing, and that will enable us to work hand in hand with designers and contractors to reduce wastage and improve efficiency. So that is amazing. All right, and I would now like to invite our fourth speaker, but before I do, could I encourage everyone just to send in your questions? There is the question and answer box at the bottom of the screen, and that's where you can type in your questions. We'd really like to hear from you, and we'll be able to take all these questions to have a discussion after our fourth speaker. So I would like to invite Ms. Aviana Onasi to the stage. Ms. Aviana is the Senior Project Associate at AGC Asia Pacific Singapore. She heads the cross-functional program in selected markets within Asia Pacific. She has a very keen interest in sustainability, promoting various solutions from AGC Group that addresses the question of sustainability in building design and infrastructure. Aviana is also a certified green ship professional, and today she'll be sharing with us on the topic of eco-friendly architectural design with Fluon ETFE film. Ms. Aviana, please.
All right, so thanks, Sarah, for the introduction. So this is our last presentation of the day. I hope you guys will continue to tune in. Okay, so let me share my screen. Yep, I hope it's up already and my voice is okay.
Yes, all good.
All right, sure. Okay, so greetings to all of you. My name is Arviana from AGC Asia Pacific, and today I'll be sharing about Fluon ETFE film. So I will start this presentation by showing you guys the project references so that you guys know how ETFE film has been beautifully installed for the projects. So the first one is Seoul Botanic Park in South Korea. This is one of the latest addition to our project list. So as you can see, it is different from the typical botanical project because the architecture is topped off with a concave roof instead of the outward protruding dome. And as we all know, the limitation of having a concave roof is that for botanical project, the center and the edge of the building might not receive enough sunlight. So by using ETFE film, it enables the unique this concave roof with a thin frames to have a sufficient sunlight. And that's why the interior is brightly lit as a result. So if you can see from this slide, if you stand outside the building itself, and when the LED lights up, it looks like this. And when viewed from top, it looks like a floral shaped greenhouse. So the lighting concept designed by Eon SLD Korea was daydreaming in a garden. With portrayal of different lights, the panels come to life at night. And as the floor panels are in different shapes and sizes, different scene combination can be created together with various colors as well as the design patterns. So that's that for the Botanic Garden, Botanic Park, sorry. So the second one is the Singapore Sports Hub in Singapore. So this project is completed in 2014. We all know about this sports hub is because of the famous retractable roof. And the roof itself is made of ETFE film, which help to reduce the overall weight of the roof and the required steel structure. The film selection is carefully considered, as this is not only to help with the solar gain reduction, but also to provide shades and to ensure optimal projection and roof illumination at night with the LED lighting itself. So I guess by now you guys have an idea about what ETFE film is and what it can do as a building material. And for those of you who are curious, ETFE stands for ethylene tetrafluoroethylene. Chemically, it looks like this. So it's the chemical structure, and physically, it really looks like a plastic film. So Fluon, which is our brand name, is a high-performance fluoropolymer film, a building material for architectural envelopes such as roofing, facade, and skylight application. And due to its flexibility, lightweight characteristic, and high transparency, ETFE film has been widely used in the recent years. And this is just a snapshot of our standard films. So we have 6 types. The clear semi-matte, semi-matte means it's just like one side matte, and also double matte, and then blue, white, as well as printed. So moving on to our unique features, ETFE film has high light transmittance, so for up to 95%. That's why it's ideal for roofing and architectural facades. But I understand in this part of the world, as in Southeast Asia, we receive a lot of sunlight. So perhaps VLT of 60 or 70% is enough. And that is possible with the printed films. The second one is that it is a light material. So it's just 0.5 kilogram per square meter. So if we translate it into a glass weight, it is just about 5%. The third one is a weatherability. The film is resistant to IR and UV. So we do a lab test as well as the on-site weathering test. We do a 30 years accelerated. So after that test, it shows that there is almost no sign of deterioration. And the fourth one is about design flexibility. So based on the 2 project references that I showed you guys earlier on, it can track many shapes, even if the form is highly complex. And it is also possible with LED integration. So I will show more project references at a later slide. The fifth one is heat and chemical resistance. The film is non-flammable. It is highly resistant to chemicals such as acids and base, and then a solvent. The film also has an anti-stick property. As for the sustainable features, we focus on the 3 items such as safety, energy efficient, and resource efficient. So first one, for the safety, because the material is very light, so in the event of natural disaster, it will not shatter like how glass will behave. And in case of fire, it does not spread and drip. The second one is about energy efficiency. So as I mentioned, it is transparent and has high VLT. So it encourages natural lighting to be implemented to the design, which means that it can reduce the electric lighting usage and as well as the cooling load, which will give you an optimum indoor environment. And the last one is a resource efficient. Okay, so the last one is a resource efficient. Since the material is very light, we don't need a lot of primary steel structure to support the material. So we can save about 30 to 50% of the structural support. It also requires lesser manpower for installation, and the installation time itself is very fast, so it's very short. It also requires lesser material and electrical costs, and that is because the film itself already reduces the electric lighting usage. That's why the electric cost is lower. And since the film has an anti-stick property, that's why this material is a very low maintenance material. So in terms of cleaning or maintenance, about once or twice per year will do. So because all of this, it gives you an overall cost saving. Fluon is also a green material whereby it is 100% recyclable. Right, so this is a table comparison between a new and a 27-year-old exposed film. So in terms of VLT, there is not much changes, just about 0.2% difference. And mechanical wise, even after it is clean, also less than 2% difference as compared to the new one. Customizable. So depending on your design requirement, ETFE film can be customized in terms of film combinations such as number of layers, colors, print, shapes, and sizes. So here is one of our project reference in China, so water tube in Beijing. We can see that each panel has different panels, different shapes and sizes. So the project uses about 300,000 square meters of Fluon ETFE film with more than 200 unique shapes. I was also informed that there are no two panels with the same sizing. Apart from the design aesthetic, design requirements also includes optical and thermal performance, so such as VLT, SC value, and U value. So from here, we can decide on the film configuration. ETFE film can be used as a single layer or a multi-layer system. So for a simplified comparison with glass, the number of layers can be loosely compared to single, double, and triple light glazing units. In fact, ETFE film, the system are very similar in performance to glazing system unit and are serving as an alternate options for this system. In the case of water tube in Beijing, ETFE panels are designed to ensure the venue is well lit during the day with appropriate levels of internal daylight, visual connection, and visual comfort. And in Southeast Asia, the typical spec for ETFE film is usually 2 layers with upper layer with the printed ones, and then transparent lower layer. As for safety performance, many people think that since it is lightweight, the structure will easily fail. But the answer is no. ETFE film cushion has high load bearing capacity and has a strong structure integrity when it is installed correctly. So don't worry, the panels will not fly out of the frame during typhoon. We do have Philippines projects whereby the wind speed is about 300 km per hour. So therefore, with careful calculation and spec selection, safety is ensured. There is always a concern for how the material will behave in the event of fire. So ETFE has been rated as a self-extinguishing with no melting or dripping of burning material. So when exposed to direct flame, ETFE film will crumple, shrink, and disintegrate if it is exposed long enough. So it just vents the fire to the atmosphere. The film has passed international fire safety standard and rated Class B S1D0, which means its smoke production is very limited and it does not produce flaming droplets. Okay, so for cushion system, how does it work? This is a cross-sectional view of ETFE cushion system. So the film layers, 2 layers in this case, are restrained in aluminum extrusion and supported by the steel structure. The cushion is then inflated by connecting it to the air inflation unit via an air tube. The pressurized air itself in between the layers serves to stabilize the film and provide structural performance in addition to the thermal performance of the system. So one air inflation unit, just the size of like a cabin baggage, can cover about 1,000 to 1,500 square meters according to the film curvature. So now I will move on to the project references so that it's easier for you to visualize how ETFE film can be applied. So the first one is Reservoir Sentosa in Singapore. ETFE film covers a wide area of RWS. We can see here that the area looks airy and spacious, and this is because there is no main structure built in the middle of the area to support the material. All supporting structures are built at the site, so at the two sides, just on top of the structures, the existing building structures. And the pattern printed on the film is a customized one. It was designed to adjust the thermal comfort level. And not only RWS, but it also extends to Universal Studios Singapore. This is located at New York Theme Zone, just outside the replica of New York Public Library. So as you can see, it is not glaring. The optical performance is still at comfortable level during the midday. So this video is actually taken at about 12:30 p.m. Next one is Tampines Hub in Singapore. We can see that there is large column-free spaces. And if you notice from the skylight, I hope you can see my cursor. So the skylight has a different panel combination according to the architect design intent. So the different panel combination gives you a sky effect. So when you at the shopping mall indoor, when you look up, it looks like a sky. Next one is Australia Embassy in Indonesia. Again, there is no big column to disrupt the view. The film is supported just by using the steel cable, and that is enough for structural integrity. So you feel that as if you are outdoor when you are actually located indoor. Next one, this is our latest project in Indonesia, just completed early last year. So Yogyakarta International Airport is the first Indonesia airport with green ship certification by Green Building Council Indonesia. So the drop-off area uses two-layer ETFE film system, which gives you an excellent optical and thermal control and shows nice LED display at night. Next one is Pakal in the Philippines. This is one of our ongoing projects for walkway canopy in between two main buildings. So this is a very straightforward. Next one is Yujiapu railway station in China. This project is rather unique, nice looking exterior design and very spacious interior. So natural lighting can also come in. At the outside, this is the close-up picture of the individual panels, and there is also a water gutter to prevent any leakage. So this is basically just the design intent. Next one is Tron at Shanghai Disneyland, China. This attraction is the main piece of Tomorrowland Park. So it has gained much attention due to its nature of the ride. So it's like a roller coaster, as well as the architectural design. So I would say that the curve wave color changing lightweight canopy suit the theme itself. If I'm not wrong, the theme is like something magical kingdom. So it brings different ride experience, and it is extremely beautiful internally as well as at night because of the LED display. The next one is the River Culture Theatre Pavilion in South Korea. This project has a bowl-shaped structure cladded in ETFE cushion to give quilted texture and silvery color to the exterior walls. Uniqlo Japan. Okay, Uniqlo Japan is actually a renovation project whereby ETFE film is installed as a double skin canopy. So it is built on top of the existing structure. So I'll play a video. As you can see, the lighting can be programmed and played accordingly. So if you visit Osaka next time, after the travel ban is lifted, you should visit Sensaibashi. It is a very popular tourist spot, and you definitely wouldn't miss this Uniqlo due to its lively facade at night. Okay, next one is Entertainment Center in Kazakhstan. This center opened in 2010, and this project is the world's tallest tensile structure at 150 meters. And since the material is very light, it just needs one 3-leg main primary structures. And LED is also part of the design to light up the facade at night. Right, the next one is arena in Netherlands. So this is a short clips to show how the construction go about from the framing to the film installation itself. So you can see very minimal manpower. If I can go back. Yeah, so it shows that maybe it's just like 3 or 4 people to install the panels, and the duration itself is very fast to complete the installation. So this is how it looks like from the interior. So it's well lit during the day. The next one, and I think this is the last project reference that I would like to show. This arena is the first commercial project in architectural industry with ETFE film. So the whole facade is covered with ETFE film, and LED lights are also incorporated to light up the whole arena. So this is how it looks like when the LEDs light up. Okay, so why AGC flow and ETFE film? Firstly, because we have a large production base, we produce our own ETFE resin in Japan and UK. So we are #1 in terms of ETFE resin as well as the film capacity. We also do have technical support, and we provide strong supply chain in the region. Secondly is excellent performance. So we do have a thicker films and UV cut grade. UV cut grade is normally meant for greenhouse projects, so it's not really for architectural projects. And then for the durable print, we also use the durable print, which is our in-house Lumiflon FEVE. It is better ink for printing, does not delaminate, and it has better adhesion. And as I mentioned during the sustainable features just now, ETFE film is a green material whereby it is 100% recyclable. Right, so I would like to spend a wee bit of time in this slide. So other than Flow ETFE film, here is our one-stop solution for sustainable building and construction. I understand that many people think that AGC is a glass company. Yes, we started as a glass company, but we have expanded to electronics, chemicals, and ceramics division. So in fact, Flow ETFE film comes from chemicals division. So firstly that I would like to mention is, of course, our high performance glass. So they are all regionally manufactured in Indonesia with Asahimas, and in Thailand with AGC Flat Glass Thailand. So I'm sure most of you are very familiar with our glass product names, such as Stopray, Sanergy, Desanlux, Topsol, Tanibelgi, and etc. The next one is Smart Glass. Smart Glass still carried by the Singapore office. So it is named Glasstech, which is a double glazing unit with LED in between the 2 panes. So it is embedded in the airspace. Yes. And then the third one, we do have a special glass. So we do have anti-reflective glass clear side. So it has a very high VLT and low iron glass. And then fire rated glass parabel with a ranging of fire rating classes from 30 minutes to 2 hours. And the third one, we do have a security glass such as like a bulletproof glass, anti-theft, anti-explosion named Stratobel. So the one that is currently hype up is energy creating facade glass. It is our building integrated photovoltaic Sun Evot. And lastly, coming from the glass division is our interior and mirror. So from chemicals division, we do have durable coating resin, which I mentioned to coat the printed films. So it is called Lumiflon FEVE. It can be used for a different kind of substrates such as aluminum frame, solid aluminum, ECP, CFC, and it can also be applied for heavy duty applications. So this coating resin have at least a 30 years warranty. And secondly, it's about high performance fluoropolymer film, ETFE film, which we just discussed much in depth about it. However, today I only mentioned about the architectural part. But in fact, ETFE film can also use in greenhouse projects under the name of F-Clean. And lastly, we also offer clean and durable sealant resin called Azestar. So it is also well known as a modified silicone. So other than clean and durable, we also provide a colored sealant for color matching purposes. So for example, if let's say your ACP in blue in color, we can provide a blue colored sealant without it being painted. And of course, this sealant can be painted as well. So this is the end of my presentation. Once again, I'm Arviana Onasi from AGC Asia Pacific. Thank you for tuning in, and I hope you guys have some good takeaways from this presentation. Thank you. Back to you, Sarah.
Thank you very much, Ms. Aviana. Be prepared for many, many questions. I see so many questions regarding your products. And now we are going into our discussion round. We just want to thank everyone for a wonderful series of presentations. Basically, we've heard from many different perspectives about what the latest trends and approaches are in architectural sustainability across like materials and design, manufacturing. And there's so much still that we don't know that we would like to hear from. So now is the time for discussion. We hope to have a really meaningful discussion. We have about 20 minutes, just about 20 minutes for Q&A. So in interest of time, what I will do is I will be filtering out some of the questions and look at those that are especially relevant to our topic today, which is on sustainability. So I will direct them to the speaker, and along the way, please continue to send in your questions. Don't worry, we'll be looking at them. But also please be assured that if you didn't get your answer today, you can always reach out to the speakers after that. Okay, so not to worry. All right, let's see who wants to go first. Maybe we can come back to Joseph since we haven't heard from him in a while. Okay, so Joseph, just to start us off, could you share with us, if somebody, a developer would like to have, the fastest way to reduce the ETTV, what would you recommend as like the simplest way or approach to do so?
Okay, so I think based on my experience, and also we can look at the formula again, the simplest way to reduce the ETTV value is to minimize the window to wall ratio. Yeah, but of course, we also have to compromise in terms of the aesthetic. Yeah? As I mentioned earlier, sometimes if the building no penetration, no windows also look not so nice. So that's why we have to balance. Yeah, what is the optimized amounts of window to wall ratio? And of course, we can try to minimize the window to wall ratio of the west and east orientation. Yeah, because east and west orientation will have the most heat gain, right? And then the second part, probably maybe we also can implement the shading, external shading. Yeah, but sometimes the problem when you apply shading, you also have to consider about the maintenance. Yeah, definitely the shading need to be clean, right? Otherwise, maybe after sometimes, let's say after 3 years, 4 years, then maybe the shading looks maybe dirty. So you also have to do maintenance. How are you going to clean the shading? Okay. And then the other option, yeah, of course, by choosing good thermal properties, yeah, for the glazing. Yeah, as I mentioned in my slide, BCR Foresta, they use the glazing with the thermal property, if I'm not mistaken, about 1.8, yeah, U value. So because of that, they are able to reduce the heat gain coming from outside. So I think this is the simplest way, yeah, how to reduce the heat gain from outside.
Great, thank you. This is very helpful. And just nice, there's another question related to that. Someone would like to know, one of our visitors would like to know, what is the difference between ETTV and OTTV, and how does that relate to sustainability?
Okay, So ETTP, basically, we only consider the aircon area. Okay, only the aircon area. So those for non-aircon area, we will exclude, not will be calculated. But for OTTV, we calculate everything. Yeah, that's why they call it overall thermal transfer value. Yeah, so in certain country, they have a different requirement. Like in Indonesia, they use OTTV instead of ETTV. In Singapore, we use ETTV. Yeah, so basically the purpose is almost the same. Yeah, to minimize the heat gain, but only the formula slightly different.
All right, thank you very much. And I would now like to invite some questions for Jose. So a question that I have is really, your projects are all around the world. How do you quickly gain knowledge on materials, culture, construction methods that are familiar and available to that specific country so that your design can be informed from there?
Good question. I mean, it has to do with definitely speaking with the client and all the stakeholders that are involved at that stage, right? So for the project in Tanzania, for example, the client and the contractor were already involved in the process. So it was quite. I mean, we could understand what was the expectation of the client right away, in terms of sophistication of the detailing or preference not to go to anything like curtain walls, or even in the lobby areas, ground floor, not to go
MS Teams, I sent you the invitation, right?
Very large panels and things like that. So we had some, it was a good process because we could be in touch with the client right away and the people on in the field. That is an extreme case because we don't have projects in Tanzania very often, but so it's more into Southeast Asia, which we are more familiar with. And in Southeast Asia, I mean, we just experience, right, years of experience around, so helps us to understand what is what culturally and also in terms of industry, what is adequate to use in different places.
Yeah, understand. Thank you so much.
Thank you.
Thank you. All right, and I would like to now pose some questions to Ferdinando. So we have got questions on Lamy glass, because also the question is that because Lamy glass is bound, by a binding agent, how durable is it when it is constantly exposed to sun and installed outdoors?
That's a very good question. Lamy glass is a kind of a wide word. As a matter of fact, there are lamy glass which are laminated using the most common material, which is called PVB. There are other PVBs, polyvinyl butyral plastic, which is, as I said, the most common. Then there are other lamy glass which are made with a so-called other material, which is EVA. EVA is ethanol vinyl acetate, if I remember right, and this has different features. And then there is a new material which is becoming quite popular in some application, which is called is a branded material. It's made by company DuPont, and it's called Centric Glass. Centric Glass is not a soft plastic like the other. It's not sold in rolls usually, but it's sold in sheets. It's thicker, typically it's very thick compared to the other. These rolls, the specific thickness is 0.38 millimeter, and you can laminate more layers on top to create a thicker interlayer of plastic, while the Centric Glass is a material which is roughly 2 millimeter thick. It's hard material, and it's mainly used in hurricane-prone areas in order and using some specific application like towers, control towers of airports, where it's absolutely necessary that the glass doesn't shatter, no matter how strong is the wind. To come to the answer is not easy to give a direct answer, but what I can tell you in our experience is that the most important part in order to have a good lifetime of and a good performance of the laminated glass is the recipe of how the glass is produced. This is paramount. The recipe is meaning that the glass normally is manufactured in a processing line, then is kind of, allow me this funny word, more suitable for a kitchen than for industrial environment, but it's cooked in an autoclave, which is like a big pressure cooker where you are cooking the glass for a few hours with a set pressure over the atmospheric pressure and at a certain temperature, which is beyond the boiling point of the water, typically between 130 and 150 degrees. The recipe that the glass maker is using is what will make the glass last longer without the problems of delamination. I'm sure that the person who's asking this may have happened to see some examples of delamination. The typical example of delamination is when you see a bubble in a window inside the glass. This bubble is simply some air that has seeped between the glass and the PVB and the material and the plastic material inside, and it's very ugly. This is something that reduces the quality of the glass and aesthetically is horrible. So the answer is the lifetime and the quality of the glass is 99% of the time depending from the recipe that each glass maker has made the laminated glass with.
Yes, I totally understand where you're coming from, because we may be talking about a cake, but the cake can be different depending on, right, what goes inside, who is making it.
Exactly.
So, yeah.
It's a concept of the recipe. Since the recipe can be made with different ingredients and with different cooking times, with different many things, this is why it's difficult to set a regulation for the glass, especially for laminated glass. Yeah.
Yes, thank you, Ferdinando, for setting that mindset. It's true. Thank you. I'd like to now move to Aviana. Some questions for you. And I will be asking you questions related to what we were talking about today. So one of the main questions is, where can we find ETFE supplier and applicator in Indonesia?
Okay. So it's still coming from, okay, supplier, right? It is not locally made. So it is still coming from the overseas. So like I mentioned, the resin is still coming from Japan and UK, and we do the fabrication in China and then ship over to Indonesia, for example, if let's say there is a project there. As for the applicator, those who can apply and install membrane structures definitely can install ETFE film. Yeah, but of course, from AGC, we do have our own supply chain, like our own team, AGC team, to do the testing, the consulting, the design team as well, the engineering team as well as the installation team.
Thank you. And also, this is quite a generic question, but I think you might be the expert on this to answer this question, which is, laminated windows energy efficient? That is the question.
Laminated, sorry, once again?
The question is, are laminated windows energy efficient?
Laminated windows, do you mean that ETFE can be used for windows?
I think it's more a generic question, but yeah, I thought since you have the wide range of products, you could kind of help to answer this question on energy efficient products, laminated windows.
Okay. So from the glass itself, we do have from clear float and then like tinted and then low E with whether it is a paralytic as well as the magnetron. So if let's say we want it to do it laminated, it's definitely better in terms of thermal performance as compared to the monolithic or the clear or the tinted glass. So I think it's referring to that, right?
Yeah, in a way.
Hmm.
Yeah. And a similar related question is somebody was wondering if it is possible to put solar panel strips or other materials into glass and to make it energy efficient or
Yeah,
energy
possible. So we do have a building integrated photovoltaic, so whereby it is like a laminated glass. So it's like a 2 pin of glass whereby the solar cell is embedded in between the two glass. Yeah, so the first glass that is facing external, it will be a low iron glass so that it can capture as much as sunlight to generate the electricity, whereby the second pin of glass that is facing indoor, it will be a low E glass so that the heat doesn't come in indoor.
Very
Thank
interesting,
you.
yeah. Very interesting. Perhaps maybe after this, maybe Ariana also can send me some information about this.
All right,
Because
sure.
I mean, as a green building consultant, definitely we can give a recommendation to our client in Indonesia. Yeah, some of them also looking for opportunity how to generate renewable energy, at the same time also reduce the energy costs. Yeah, so this could be a solution for them.
All right, sure.
Yeah, because Aviana, you shared so many products, and there were many questions here that were very, they wanted to know about bulletproof glass,
Wow.
spray-rated glass. So I think I would like to direct whoever is interested in these specific products to just speak with Miss Aviana, and she will be able to answer your questions fully. So I would like to draw us back and probably answer maybe 2 more questions so that we can close for today. So the question that I'm gonna read out is open to everyone to answer. Okay, so the question is whether the green building is passive or active kind of designed approach. How much initial cost increment to building are we looking at compared with standard solutions? So like, if somebody were to use like the most advanced green building materials, what would that maybe look like compared to going for more conventional materials? Somebody who want to answer?
I think this is very interesting question. Yeah, maybe if you don't mind, maybe I will try to answer based on our experience.
Yes,
because
please.
many times as a green building consultant, our client always asks us, yeah, what is the additional cost? How much is additional cost if they are going to go for, let's say, green building certification? Okay, so based on our experience in Indonesia, because Indonesia actually green building itself only being promoted since 2010. So before that, there's no green building rating tools. And up to now in Indonesia, green building still a voluntary basis, yeah, not a prerequisite or mandatory as like in Singapore. So for our green building project in Indonesia, when there's a project want to go for green building, right? And then every design must comply to the green building requirement. And then everything must be calculated in more detail, yeah, like what is the load profile, right? And also the glass, the ETTV building envelope. And ended up, after we try to comply to the green building requirement, actually we found that they also can save a lot of money, not only for the operating cost, but as well as initial cost. Why? Because without green building requirement, yeah, sometimes they just calculate maybe how to say, they just calculate based on assumption, yeah, maybe, yeah, because this one a bit sensitive, and ended up when we use the green building requirement, then we found that actually the calculation is a bit on the higher side. So we have to reduce it, yeah, especially on the cooling load system. So there's one project, my project, yeah. Initially, the consultant calculated the load was around 5,000 ton, yeah. And then after we do the calculation, we found that actually the load is only around about 3,000 ton. So the difference can be 2,000 tons. Yeah, I'm talking about the chiller system, right? And then after we explain to the developer, and then finally we compromise, and then they agree to reduce it to 4,000 ton. So can you imagine they are able to reduce 1,000 ton of chiller system, which is equal to 15 billion rupiah. Yeah. So if there's a people ask, if I apply or comply to green building requirement, does it mean that I have to spend more money? For Indonesia case, maybe not true. Maybe they can save money. Yeah, because we help them to identify which one that maybe not necessary for them to spend that amount of money. Yeah, but generally, maybe I can say that if they plan the green building design from the beginning, from day one, probably the additional premium cost, maybe I think maybe around 2%, 2 to 5%. Yeah, probably can be less than that. Yeah, so this is based on our experience. Yeah, maybe to Singapore context a bit different because in Singapore, green mark is prerequisite mandatory. So every building must comply to green mark. Yeah, so very hard to justify. Yeah, and then when you go to platinum level, then there will be additional premium cost for you. But of course, you can gain more saving. Yeah, green mark platinum, you can save up to 30% energy saving, which is very, very significant. Yeah, so hopefully my answer, can satisfy to the questionnaire. Yeah, is it answering the question?
Yes, thank you. I think that this question is, it really is probably in everyone's minds and also reflects an existing perception of cost that, green might mean more expensive, but what you're saying is that that is not necessarily the case. And there can be a way for us to look at improving sustainability. It's very feasible for us to do so.
Yes.
So yeah, thank you for that. And I would like to now wrap up our webinar. But what I would like to do is to have everyone answer this one question, which is, what are your hopes for the facade industry? And if you could summarize it in one line, what would that be? And now I'd like to go one round so that all of you can share your perspective, and that is how I will bring it to an end. So who would like to go first? One line for what your hopes are for the facade industry.
I go first.
Sure. Please.
One line, active glass, whatever it means. Active glass can be glass with solar paneling included. Active glass can be glass which change color or become a screen to create maxi screens. Active glass may become a shade, which is let's say electric driven shade, which turns the glass transparent when it's needed and can turn the glass for privacy or for saving from too much light or heat or sun during the peak hours. Active glass is the future.
Okay, active glass is the future. Thank you, Mr. Ferdinando. Who would like to go next?
Say something?
Oh, okay, yes, please.
Maybe the facade is part of the total building ecosystem where it's almost like self-sufficient building in terms of production of energy, reducing emission of carbon dioxide, potentially even producing oxygen, part of the total ecosystem of the building. That would be, I think, would be a very nice achievement.
Yeah, that is a good aspiration. Everyone heard that? Materials, builders, consultants, yeah? All right, and who would like to go next?
Perhaps maybe if I may, I just want to share that at this moment, I think one issue that very crucial that everyone must aware is regarding to the carbon emission. I don't know whether everyone aware how bad is our situation at this moment. Yeah, so we don't have enough time. Yeah, other than we have to change and we aware that we do something, towards sustainability. Yeah, because as you know that the climate change now, the temperatures keep going up, right? It's more electricity consumed and means more carbon emission. Yeah, so this will make our environment suffer and also suffer for us. Yeah, so I think this is more important rather than just money. Yeah, we only have one Earth, right? What happens if we damage our Earth? So we have no place to live. Yeah, so this is something that we really have to care and consider. Okay, so I think that's all.
Very well
Thanks.
said. Thank you, Mr. Yusuf. And Ms. Aviana?
Yep, so I agree fully with Pak Yosef that, I mean, as a whole, sustainability is the new normal. Like, it is not like, okay, I want to do it tomorrow, the future, but it is what we have to do now, right now. So it is the new normal, especially when we are living in this climate emergency, I would say. So the urgency is there. And so the impacts of construction and the built environment is very crucial. The choice of materials has to be considered carefully when we want to build something. And of course, it does not mean that we have to be less creative, like just use the same thing over again, but rather be more willing to try something new that is more green, more sustainable. Because after all, sustainability is for the people and the environment. Yep, thank you.
Thank you, Ms. Aviana. That was a really, really nice way to end our discussion round. You were saying that we have to take action now. So I would just like to summarize what I've heard today. There were many questions, very interested in the materials, the methods, calculations, and also, of course, feasibility. Can this be done? Does this make sense? And we've heard from all of you. I hear a lot of the words active. If only the material itself can be active, and then it can become a system that is active, self-sufficient. And then we then talked about actually our own mindsets. We have to be actively aware of the carbon footprint that we are leaving behind, the impact that we are causing on our earth. And what Aviana ended off with is that we have to do it now. There is an urgency. And I like what she said that, you know, it doesn't mean that we have to be less creative. And that's where we need our design partners as well to dream and to continue to lead the way, and we can work together to make this happen. So I'm really happy to bring this discussion to a close. Thank you again. All right, so we have now come to the end of the webinar. I would like to thank all of you who are here with us. Thank you for joining us today. We really hope that you've taken away some valuable insights. There's just so much knowledge here, and you know that you can always reach out to them for more information. So I'd like to thank all our speakers once again, Mr. Joseph Lim, Mr. Jose Claudio Silva, Mr. Ferdinando Lucchesini, and Ms. Aviana Unasi. Thank you to our sponsors, AGC Asia Pacific and DSA Group Asia 2. Do note that there are other exciting webinars coming up. This is not the end, so please look out for that. What will be coming up next is Glasstech Asia times PERAFI webinar series number 4. And the topic is going to be on digitalization and the future of facades. That's going to be on 18 November at 2:30 Jakarta time, same as today. It's going to be a power-packed presentation and different perspectives from different countries. Also, do remember to check out our other BAO events. We have information on BAO, BAO China, Digital BAO. They can all be found on our website at glasstechasia.com.sg. Follow us on our social media on LinkedIn and Facebook as well, so that you don't miss out anything. And we'd also like you to please scan the QR code after this that you see on the screen. This will lead you to take part in the survey. Your feedback is going to be very, very useful for us to ensure that we continue to deliver content that is meaningful for you. All right, so this brings us to the end of the webinar, and we really look forward to seeing you at our next one. Have a wonderful Wednesday.
For over 20 years, Glasstech Asia has served the Asian glass industry as the main meeting point in the region. Together with Fenestration Asia, Glasstech Asia moves around Southeast Asia and regularly attracts over 200 suppliers showcasing leading technologies together with more than 3,500 buyers from the region.